Welcome to the deep dive. Today, we're really getting into something fundamental. Why do AI systems sometimes mess up? Even the smart ones.
Yeah, exactly. We've got this great case study looking at the built-in reasons why AI might make mistakes. The structural possibilities, you could say.
Okay, so our mission here isn't just to point out errors, but to understand the why, to dig into those root causes based on this study.
Right. We see the weird outputs, the wrong answers, but this helps us look under the hood. How AI actually learns and where things can go off track.
So let's start with the basics mentioned here. AI often learns using inductive reasoning, meaning it sees specific examples and tries to make general rules.
That's a good way to put it. Like, touching one hot stove teaches you all hot things might burn. It generalizes.
But that generalization, that's also where the problems can start, according to this material. It highlights two main ways errors are sort of baked in.
Precisely. The first one they talk about is generalization discrepancy. Basically, the rule learned from a small part of the data.
The local data.
Yeah, the local data, it might not actually work for the bigger picture, the global reality.
Okay, and they have that Arctic fox example, right, which I thought was pretty clear.
hmm So imagine an AI learning to identify Arctic foxes, but it's training data, only pictures of white Arctic foxes.
So it learns white fur occurs Arctic fox. Simple enough locally?
Exactly.
Yeah.
But then, what happens if it sees a gray Arctic fox? Because, they exist, especially in summer.
Huh. The AI might just fail or misidentify it because its rule white equals Arctic fox doesn't hold up anymore.
Right. The local generalization wasn't globally true. It's like learning a word in only one context and being confused when it's used differently.
So it's not just how much data, but the variety within it. That's crucial.
Definitely. The AI made a leap based on, incomplete info, from the specific white foxes it saw to all Arctic foxes.
Okay, that makes sense. What's the second structural error type they mentioned?
That one's called pattern discrepancy, and this is about the fact that AI can really only recognize patterns it's actually been trained on.
Right. So if it meets something totally new, an unlearned pattern, what does it do?
Well, it tries its best. It tries to fit that new thing into the closest box it does know, which, can lead to some odd mistakes.
Like the example with dogs and apples.
Yeah, that's the one.
Mm.
An AI trained only on identifying dogs and apples.
Mm.
Nothing else.
Okay.
Now, you show it a picture of a fox. It hasn't learned fox.
So it looks at the fox, 4 legs, fur, kind of pointy ears.
And it thinks, well, that looks kind of like a dog. It's closer to dog than apple based on its limited training.
So it just labels the fox dog, even though it's wrong. It's like forcing a square peg into a round hole because you only have round holes.
Pretty much. It's trying to map the unknown onto the known, based purely on the patterns it has learned.
So these aren't like random glitches then. These errors come from the very way AI learns.
Exactly. There are consequences of inductive reasoning and finite training data. It's inherent in the process. Understanding these two things, the generalization gap and the pattern gap, helps explain why AI stumbles.
Okay, so let's just quickly recap. We've got AI learning by generalizing from examples.
Yep. Inductive reasoning.
And two big potential pitfalls. One, making broad rules from limited local data that don't always work globally, like the Arctic fox.
Right. Generalization discrepancy.
And two, encountering totally new patterns and basically misidentifying them as the closest thing it does know, like the fox being called a dog.
Pattern discrepancy. That's it.
So, thinking about this, it really makes you consider things, doesn't it?
It does. And here's something for you, the listener, to think about. As we use AI, more and more things, self-driving cars, medical tech, all sorts of things, how did these built-in limitations affect things?
Yeah. How does it influence how reliable these systems are? And maybe more importantly, how much should we trust them, knowing these potential issues aren't just random bugs, but part of how they function?
It's definitely something to keep in mind as this technology continues to develop. Understanding the why behind the errors is key.